Right triangles provide more information than any kind of triangle. You know the measure of one angle, the right angle. You also know that the other two angles are acute angles. When we are given a right triangle, we also have another way to prove triangles are congruent. If the hypotenuse and a leg of a right triangle are congruent, then the two triangles are congruent. This technique is a theorem because we can prove it is true. Again, we have to make sure the points are listed in the correct order so the corresponding parts of the triangle are matched. So this is our last triangle congruence postulate or theorem, our last way to prove triangles congruent, and that is hypotenuse leg. Right. Must be a right triangle, and you must be able to show that the triangle is a right triangle. Either in this case, our angle was given to us as a right angle. So here notice that angle A and angle D are both given to us as right angles. Or something that allows you to prove an angle is a right angle, like perpendicular lines. So let's take a look at hypotenuse leg a little bit more. Right, so hypotenuse leg. If the hypotenuse and a leg of one right triangle are equal to the corresponding hypotenuse and leg of another right triangle, then the two triangles are congruent. All right, so here in this case, we have, I'm going to write that a little nicer, we have two triangles here, and we are given that KL is congruent to NO. That is the leg of the triangle. All right, so we know it's a leg because it's not the hypotenuse. Right, so KL and NO are legs of the triangle. Triangle has two legs if it's a right triangle. The hypotenuse is opposite the right angle. Right? So you just look to the right angle, opposite that angle, there we go, is the hypotenuse. Right? So JL is congruent to MO, and that is the hypotenuse of both triangles. So if that's true, then triangle JKL is congruent to triangle MNO. This is in your notes, all right? So I want you to write this information, and then I want you to write one more thing underneath, provided the triangles can be shown to be right triangles. Because if you can't prove the triangle's a right triangle, you can't use hypotenuse leg. Right? So if you have a right triangle, make sure you check if hypotenuse leg applies. So if none of the other theorems apply, because we could still have side, side, side if we know three sides in one triangle are congruent to three sides in the other triangle, even if it's a right triangle. Or if we had, for instance, if we knew the two legs were congruent and there's a right triangle, then we'd have side, angle, side, right? Because we'd have two sides and the angle between. But if none of those works out for you, if none of the other four work out, and it's a right triangle, see if it's actually a hypotenuse leg. So let's talk one more thing I want to talk about in this podcast. Right, and that is, as soon as it changes, and that is, did I not hit it? Well, it's never going to change if I don't hit the page. There it is. Why does hypotenuse leg work? Oh, I have a feeling I hit it twice. Well, if it changes my page, we'll just change back. All right, so, and there it goes. So let's change back again. Hopefully it'll only change one page. And it's thinking about it. There it is. All right, so recall another theorem for right triangles, and that's Pythagorean theorem. All right, so c squared that's the hypotenuse. And a squared and b squared, those are legs. It doesn't matter which leg is which. So if we take the hypotenuse squared is equal to the sum of the two legs squared. So if we know the lengths of two sides of a right triangle, we can solve for the length of the third side, and that would be using Pythagorean theorem. I'm going to abbreviate because I'm going to run out of space. Hypotenuse leg congruence theorem applies when the corresponding hypotenuse in one of the legs is congruent. When this is the case, the two right triangles are congruent. Right? Because if we didn't just know that they were congruent, if we didn't just know that, for instance, that JK was congruent to MN, and JL was congruent to MO, right? If we knew the measurements, so say this one was say this one is 6 and this one is 10, okay, then we could just use Pythagorean theorem and we would solve for the missing side. By the way, that missing side would have been 8. All right, so because Pythagorean theorem holds for right triangles, anytime we have two sides, technically we can know, we could have always used Pythagorean theorem to find the third side. Right? So if those two sides happen to be a leg and a hypotenuse, we can prove the triangle is congruent using hypotenuse leg. And you might say, well, what if it were two legs? What if we had this? Could we still prove the triangle is congruent if we knew the two legs were congruent? Well, yes, it would just be side angle side. All right, so because with a right triangle, anytime you know two sides, you can find the third side. And matter of fact, if two sides are congruent in a right triangle, the third side is going to have to be congruent as well. And if it's two legs, it's side angle side. Two legs and a right triangle, it's side angle side. If it's a leg and a hypotenuse, it's hypotenuse leg. All right, so no matter what, if you know two sides on a right triangle are congruent to two sides on another right triangle, some theorem is going to apply. So actually, I'll fill this out, ABC, and we'll just call that, of course, DEF. And so in this case, triangle, so I can squeeze it in, ABC would be congruent to triangle DEF using side angle side. Can I move that out of the way? No, it goes the whole page. But actually, I have a little bit of space. So there, now I can fit my little picture there. All right, so that's why hypotenuse leg works, because right triangles are special, and we can only use Pythagorean theorem with a right triangle, and so there's a special relationship between the sides. We're going to be using hypotenuse leg as well as all the theorems that we've learned to prove triangles congruent, or maybe we can't prove triangles are congruent. So stay tuned. Bye for now.